By the end of this chapter, you should be able to recognize the SOLAS requirements for steering gears and the steering compartment. State what provision must be made for recharging the steering gear. Identify the correct operation and setting of relief valves on hydraulic steering gears. Regulations regarding steering gears are set out by the International Maritime Organization, the IMO, in SOLAS. Many of the rules for steering gears set out in SOLAS are based on lessons learned from the grounding and loss of the tanker Imoko Cadiz in 1978. There are many different combinations of steering gear that will satisfy the requirements of SOLAS. There are also some special provisions in SOLAS for certain types of older ships. There are also an increasing number of non-standard arrangements, such as podded drives, coming into use on modern ships. In all cases, flag states and classification society rules ensure that every ship will comply with or have equivalence to the SOLAS requirements. The key point for ship staff is that they understand how to operate and test their own steering gear in order to comply with the requirements of SOLAS. To see what SOLAS has to say about the requirements for the steering gear on different ship types, click on each of the hotspots shown. Every ship must have a main steering gear and an auxiliary steering gear, but there is no need for an auxiliary steering gear if the main steering gear has 2 or more power units, and after a single failure in its piping system or in one of the power units, the defect can be isolated so that steering capability can be maintained or speedily regained. There is no time limit set for this in SOLAS. Each hydraulic reservoir must be fitted with a low-level alarm to warn of an oil leak. Audible and visual alarms must be given on the bridge and in the machinery space where they can be seen. Relief valves are provided to reduce the risk of hydraulic pipes bursting. A main steering gear is one which is capable of putting the rudder over from 35 degrees on one side to 35 degrees on the other side with the ship at its steepest seagoing draft and running ahead at maximum ahead service speed and, under the same conditions, from 35 degrees on either side to 30 degrees on the other side in not more than 28 seconds. The reason that the time for rudder movement is only measured from 35 to 30 degrees is that in many steering gears the rate of steering pump delivery is reduced as the rudder nears its desired position. The rudder will therefore slow down during the last 5 degrees of movement, so the time for this part is excluded from the time measurement to give a better idea of how fast the rudder can move when the steering gear is working at its full capacity. An auxiliary steering gear is one which is capable of putting the rudder over from 15 degrees on one side to 15 degrees on the other side in not more than 60 seconds with the ship at its steepest seagoing draft and running ahead at 1/2 of the maximum ahead service speed, or 7 knots, whichever is the greater. By the end of this chapter, you should be able to list the routine checks and maintenance to be carried out on the steering gear by ship staff. Properly installed and operated hydraulic steering gears should need only a minimum of maintenance, mainly lubrication of moving parts. Work that involves opening the steering gear up for inspection or repair is usually only carried out in dry dock with the assistance of the manufacturer. Like all hydraulically operated systems on board ship, proper attention to the cleanliness of the hydraulic oil is a key point. Wear on moving parts, such as the sealing strips on rotary vane units and moving parts in the hydraulic pumps, should be minimal if the hydraulic oil is maintained in the proper condition. A leaking hydraulic system, combined with poor arrangements for topping the system up, meant that air, moisture and debris which had entered the steering gear hydraulic system may have contributed to the loss of the tanker Imoko Cadiz when her steering gear failed in heavy weather. On a daily basis, the steering gear system should be checked as follows. Check the system and storage tank oil levels. Check for oil leakage. There should not be any visible leakage. If there is, this needs to be investigated and repaired at the first opportunity. Check for abnormal noise. Air in the system or mechanical failure will give rise to noisy operation. Excessive vibration can cause fatigue in hydraulic pipes, which will weaken them. Make sure pipe clips are secure and try to stop the vibration. Check any pressure gauges and ammeters that are fitted to the system. Become familiar with their normal readings so that you will recognize when something is wrong. Pressure gauge valves may be kept shut between readings to minimize damage from pressure surges. Higher than normal pressures may indicate partial seizure somewhere or extra friction due to a loss of buoyancy in the rudder. You should become familiar with the movement of the rudder while on autopilot at sea. Whilst there will be more frequent and larger movements in bad weather, similar movement in good weather may indicate incorrect control settings or hunting due to air in the oil. These can lead to excess wear or possible loss of control. Slow changes in rudder angle towards midships while you can hear that the pumps are not delivering is a sign that a valve is leaking. You may be able to hear or feel the oil passing through it. Changing over pumps may temporarily fix this. Remember that when testing gears, which must normally be done at least 12 hours before leaving port, in addition to checking operation, your checks will include the following: a visual inspection of the steering gear and its connecting linkage, the full movement of the rudder according to the required capabilities of the steering gear. Unusually jerky movement suggests partial seizure somewhere. The emergency steering drills must take place at least once every 3 months in order to practice emergency steering procedures. These drills must include direct control within the steering gear compartment, the communications procedure with the navigation bridge, and, where applicable, the operation of alternative power supplies. This may be a good opportunity to operate valves which are not normally in use, but may be needed in an emergency. Tests on the isolating valves of the steering gear on the tanker Amoco Cadiz after her loss showed that these valves, which had been painted in the open position, could not have been closed. It was recommended that such valves should be periodically opened, closed and lubricated where necessary to ensure that they would operate in an emergency. Maintenance recommendations will vary depending upon the size and type of steering gear fitted. Regular testing of hydraulic oil samples may be all that is required to monitor for internal wear. Some manufacturers recommend that rotary vane steering gears are opened up for inspection every 5 years when the ship is in dry dock for class survey. Typical work would include change of actuator bearings if worn beyond or close to tolerances, change of any other parts subject to wear, change of ram or vane seals if the material is known to weaken with age, change of system oil. Some manufacturers also recommend changing system oil every 2 years. Moisture can be gradually absorbed and turned to compressible steam when the oil gets hot. Most manufacturers recommend that this work is undertaken by one of their own service engineers. The steering gear should also be thoroughly checked if the ship is grounded. Routine checks of the steering gear. Testing steering gear. Major work on the steering gear. Here is a reminder of what we have covered in this chapter. Move the mouse over the slides if you would like a reminder of the main points. If you're not sure of anything, you can go back over it again. Once you're ready, move on to the next page for an end-of-chapter assessment.